Greetings, math friends. We are going to take a look at this integral, but we know what this integrates to. We have a variable as the upper bound, though, and that's what we're actually going to solve for. When we have this function integrated from 0 to alpha, and we know that it equals 15, what will alpha be? All right, so how are we going to solve that? Well, we are going to approach this essentially the same as we would any other integration. We first want to find the antiderivative. All right, but we also know that this is equal to 15. Okay, so antiderivative terms that we're going to evaluate here, and it's equal to 15. Now, right off, some of you may notice that if we plug in 0 into all of these values, they go to 0. So that's nice with this problem that we don't have to account for that. We're going to plug in alpha into all of these. All right, so the second half of this would be 0, so I'm not going to put that in there. And then this is going to equal 15. All right, so now we would need to solve this fourth order polynomial equation for the value 15. What can I plug into alpha here to get 15? The typical approach that we want to do when we solve polynomials like this would be to take the 15 to the other side, so this is equal to 0, and then we are essentially finding roots at that point for this. So that would be the technique to do next. And then a situation like this where we have the fourth root, I would want to go in here and start doing some synthetic division if I was trying to find this in an algebraic way. Another way that you could do this is graphically. We could put this into some kind of graphing software and see if we can find some solutions. Now, there's a possibility that the solutions for this might be complex, so the graph approach won't work for us. If you can see some particular factoring technique, that might be an approach to do also. Today we're going to just go with the values that we get from the graphing approach, and we're going to find that alpha can be negative 2.665 or 2.279. So our focus has been on the calculus today and the algebra up to this point, and we are using the graphing approach to find these solutions. With a quartic polynomial like this, you're probably going to have to go through a process of several trial and error steps, most likely, especially if you take the synthetic division or even potentially the long division approach to that, using a theorem that tells us that when we divide this by some term, that the remainder is the value at that. So that's the remainder theorem. Hopefully this has been interesting. Try to find some calculus in your part of the world to discuss with someone else. Challenge yourself. Cheerful calculations.